So if the production of X yards of cloth costs C of X dollars, C prime of 100 is going to represent how fast C of X is changing when X is 100. So when we are producing 100 yards of cloth, C prime of 100 is the rate at which cost is changing, right? It's how quickly, right, the cost is increasing or decreasing. Its units would be in, what do we think? What are the units for C of X? What are the units for the cost? They're in dollars, right? It tells us as part of the problem, right? C of X dollars. And X is measured in what? Yes, it's length. It represents how much cloth we have. It's in yards. That's also part of our prompt here. So if cost is measured in dollars and X is measured in yards, then C prime of X is going to be measured in dollars per yard, right? The output that we're measuring the change of is C. It's in dollars, right? And what we're measuring that change with respect to is how many yards we're making. So dollars per yard. Right? Remember, it's always the change in the output over the change in the input. What we're effectively doing is taking an average rate of change over a very small period of time. So we're still going to see output units on top and input units on bottom. So dollars per yard. Often this value, this derivative value, is used to estimate how much it would cost to make the next yard, right? So if C prime of 100 were something like $2, right, per yard, right? It's in dollars per yard. That's telling me that if I've made 100 yards, to make that 101st yard, I should budget about $2. If I wanted to make 1 yard more. It may not be exact, but it's telling me how fast that the cost is changing at that instant. So it might be a good estimator. This is called marginal cost. Marginal in business is usually just a fancy term meaning the derivative of. Okay. So this is called marginal cost. We'll talk more about marginal functions in chapter 3, so it's not necessarily something that we have to put to memory now. But in business, again, marginal usually refers to the derivative of. So marginal cost is the derivative of cost, how fast cost is changing. It may estimate cost of the next unit. Or the unit immediately previous, right? We might use that instantaneous rate of change to talk about the rate of change in kind of like a bubble around that time, right? If you were going 60 miles per hour 1 hour into your journey somewhere, then likely 59 minutes into your journey, you were also going 60, and an hour and 1 minute into your journey, you were going 60. So how much did that 100th yard cost? $2. How much did the 101st yard, would it cost if I made it? $2, right? We might use it as an estimate for both. That way we don't have to look at how much did it cost to make 99? How much did it cost to make 100? How much did it cost to make 101? Right? If I have some model that is telling me how much it costs to make 100 and how fast it's changing at 100, then I can use that value for an estimate. All right.